Do you recognize this number? This is the golden ratio, also known as phi. It is approximately equal to 1.618. What's so special about it? Well, it is said to be found across all of nature, in human body proportions, plants, flowers, and even art. The concept of the golden ratio has first been recorded in the book Elements, written by ancient Greek mathematician Euclid. But what exactly is the golden ratio? Suppose we have a segment with a length of a plus b, where a is greater than b. If the ratio of a plus b and a is equal to the ratio of a and b, then you can say that a and b have a golden ratio. Let's take a look at a golden rectangle. The ratio of its long side to its short side is phi. Now, if we put another golden rectangle inside, and another inside that, and so on, if we draw a curve through all these shapes, we get what we call a golden spiral, which is claimed to be observed quite often in nature, especially in plants, which we will talk about later. The person responsible of making the golden ratio so famous is Leonardo of Pisa, also known as Fibonacci. He was famous for bringing Hindu-Arabic numerals to Europe, which made arithmetics way easier because Europe used Roman numbers. In order to teach people how to use these numbers, Fibonacci wrote a book called Liber Abaci, and in chapter 12, there was a problem about rabbits that made him famous. Imagine you have a pair of rabbits, one male and one female. Starting from the second month, every female reproduces a new pair of rabbits each month. How many rabbits will they produce after 1 year? Well, we notice each month the number of pairs is equal to the sum of the pairs in the 2 previous months. Therefore, in 12 months, you get 144 pairs. This is the famous Fibonacci sequence. It's a series of numbers in which a number is the result of adding the 2 before. 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 2 is 5, and so on. Mathematically, it is represented by the following formula, where n is greater than 1. You're probably wondering how this is linked to the golden ratio. Well, as you go on in the Fibonacci sequence, the ratio between the numbers gets closer to phi. In the 19th century, it was discovered the sequence could be found in the formation of many plants. Fibonacci numbers can often be found in the arrangements of leaves around the stem. This maximizes the space of each leaf and maximizes sun exposure. Now, this explains why the growth of plants is linked to the Fibonacci sequence, but how? Scientists are still trying to figure it out.